Hey there, awesome physics students. Let's talk about conductors and insulators in electricity. The defining characteristic of a conductor is that charges can move freely inside the conductor. And of course, the defining characteristic for insulators is, well, you guessed it, charges cannot move freely. Okay? Now, of course, there's a continuum here between can move as free as possible and cannot move at all. In reality, there's going to be some objects or some materials in the middle here where it can kind of move and kind of not move. But just for the sake of learning electricity, let's adopt the idealized versions of a conductor where they can totally move freely and an insulator where they cannot move at all. So let's talk about conductors first. Imagine you have a conducting rod here. This is a conductor. And you put negative charges at the end. Now, what happens to those negative charges? They're allowed to move freely. And you know that like charges repel. These negative charges don't like each other, and they want to get as far away from each other as possible. And so that's what they're going to do. If you look at this rod one instant later, then the negative charges are going to be spread far apart as possible to get away from each other. And this is true if you have let's say you have a conducting sphere, like a ball or something, a globe, and you put negative charges on the end. Of course, 1 second later, the charges are going to try and get away from each other as much as possible, and so they're going to be spread far apart. Insulators, on the other hand, let's talk about that. So this is an insulator. If you put negative charge on the end of an insulator, the charges cannot move freely. Of course, these charges don't like each other, but that doesn't matter because they cannot move freely. And so those charges, if you put them there, they will stay there and they cannot move. And even if you put equal numbers of positive charges at the end, and these desperately want to combine to be overall neutral, they will not do it because they cannot move freely. Now, interestingly, if you took like another rod here, and you took, let's say this is a conducting rod, and you put that here, and it's totally neutral. Remember that totally neutral objects still contain positive and negative charges. They just don't have an excess of either. The positive charges in this conducting rod are going to be attracted to the negative side here in the insulator, and the negative charges in the conducting rod are going to be repelled. Now, of course, we know that on the outside of atoms are the electrons, and the electrons are the things that actually move in these cases, and that the protons in the nucleus don't move, so the positive charges do not move. However, we often talk as if the positive charges are allowed to move, so I'm just going to do that from now on, and keep in mind that it's just a language thing, and that really it's the electrons only that are moving. So the electrons are going to repel from here, and they're going to congregate down here, and that's going to leave an excess of positive charges here, and so we're going to have positive charges up here. Now, interestingly, what I can do here, so in bringing it in contact, I'm polarizing this. I'm creating a polar object, a conductor, just by bringing it close to another charged object. Now, if I take the ground here, and the ground is an object, that's the Earth, that we treat it as an infinite reservoir of positive and negative charges. And that means that I can dump as much positive charge as I want to in the ground, and it will continue to accept it, but the ground will remain neutral itself. Similar, I can dump as much negative charge in there too. Or I can pull as many negative charges out of the ground as I want to, and it will keep giving them, and it won't change. The ground will not become positive or negatively charged. So I can attach a wire here, a conducting wire, to the ground, and what's going to happen is, well, the negative charges are up here. The positive charges in the ground are going to be attracted and to the negative charges up here, and they're going to move up in this rod, and this whole rod is going to become positively charged in trying to get close to the negative charges here. The negative charges are going to move into the ground. And this is called, and then what I can do is I can just break this wire, and now I have a positively charged rod that I got to be positively charged by not even touching the charged rod up here. That's called inductively charging it. right? When you charge something up, not by touching it, but by just relying on the attractiveness of opposite charges and pulling, allowing the connecting two objects that are overall neutral.